Graph value tree. This is a premium medium problem. So you have a graph of n nodes leveled from 0 to n minus 1. You are given an integer n and a list of ages where ages of I is ai bi indicates that there is an indirected age between nodes ai and bi in this graph. We have to return true if the ages of the given graph make up a valid tree and false otherwise. Let's see this first example. Here we have 0, 1, 2, 3, 4, 5 nodes and n is 5, and these are the ages from 0 to 1, 0 to 2, 0 to 3 and 1 to 4. So clearly we can say this is a tree because I don't see there is any cycle and all the nodes are connected, and also there are few other conditions we'll discuss about later. Now check the second example. N is 5. Here also we have 5 nodes. But you see there is a cycle here. Right? From 1 to 2, 2 to 3, 3 to 1. This is a cycle. So this is not a valid tree. Now here we have few graphs. We'll just see they are trees or not. So the first one, it doesn't have any cycle. The number of nodes is 1, 2, 3, 4, 5. Number of edges 1, 2, 3, 4. So number of edges equals to number of nodes minus 1. And there is no cycle, all the nodes are connected, so this is a tree. Second one, we see there is a cycle. So straightly we can just say this is not a tree. But how we will detect this? Let's say we are traversing from this node, right? Either using VFS or DFS. And we reach here, let's say we are doing DFS, we reach here, then we reach here, then we'll just see 3 has 1 over 1, right? So, but that is already in the coming path, right? So, we'll detect the cycle, we'll see this is not a tree. Similarly, if we are doing VFS, same way, we'll just traverse this and then this layer. So for 1, you will traverse this 2, 3. For 2, again you will traverse 3, then but you will see the 3 is already visited. So you will detect one cycle. So now this one, it has no cycle. The number of nodes 1, 2, 3, 4, 5 and number of edges 1, 2, 3, right? So the number of edges not equals to number of nodes minus 1. So this is not a tree. This is basically a forest. Also there is another way to detect this. If we just traverse from any node, let's say 0, we'll traverse 1, you will traverse 2, but these 2 nodes you will not traverse because they are not connected. You will stop your traversal here, right? So the number of nodes you traversed is 3, but just because these all the nodes are not connected, you won't be able to traverse n nodes. Let's see this one. The number of nodes 1, 2, 3, 4, number of edges 1, 2, 3. So number of edges equals to number of nodes minus 1. So that condition is satisfied. But still this is not a tree because one thing is there is a cycle, and second thing is all the nodes are not connected. But how you will check in your code? Let's say you are traversing from the node 1, right? Then you will traverse 2, 3 and then you will detect this cycle, right? But let's say you are traversing from 0, then you will not reach this 1, 3 to this nodes, right? You will not even detect the cycle. But even in that case, how you will detect, how you will get the, I will say that this is not a tree. Should we traverse all the nodes and say find the cycle? No, because if you traverse from 0 and if you start from 0 and you are not able to visit all the nodes, that means there are some isolated nodes and this is not a tree. This cannot be a tree. This will be forest at least, right? So uh, if you are starting from 0, we can just keep a counter, right? If we'll just see after all the DFS traversal or BFS traversal, if we are just visiting n number of nodes or not. So if graph is a valid tree, if these 3 conditions are satisfied, like number of edges will be number of nodes minus 1, there is no cycle, and the graph is not a forest, right? All the nodes should be connected. Now let's see the code now. So first I will check if number of edges, that is length of edges, not equals to n minus 1. Then I can straight away return false. This is not a tree. Next I'll populate the adjacency list. So that will be a list of list, and each item is one empty list for each node. For each edge, A, B, A in edges, this is an undirected graph, so both A and B are neighbors of each other. Right now I have to do the processing. I will do a BFS processing here. I will take one queue. This is a DQ, and we need a visiting set, right? So visiting set is basically a set that will keep track of the currently visiting nodes. And if we are traversing a node, if we are finding a node that is already in the visiting set, then we can say there is a cycle. But there is a catch. Let's say you are starting from 0, you reached 1, right? 1 has two neighbors on 0 and 4, but here 0 is already in the visiting set because you came from 0. But will you say that there is a cycle? No, right? Because like 0 is the parent of 1. So if it is not a parent, if the neighbor is not parent, then only we can say there is a cycle. So first, so we need to keep track of the parent as well. So DQ we can initialize with 0, and let's say its parent is -1. Right now I am going through the queue, and I will pick node and parent, that is from the queue I am popping. This is popping from the left side, and every time I am popping one node I will be visiting that, right? Visiting dot add node. Now I have to go through the neighbors. For neighbors in adj of node, if this neighbor is not equals to parent, right? If it is a parent, of course this will be in visiting set, right? If it is, because it's coming from that node. If it is not the parent but still this is in visiting set, that means there is a cycle. So it's like that. Let's say 1, then you reached 2, then you reached 3, then 3 to 1, if there is an edge, then you can say there is a cycle. But 3 to 2 is there is no cycle. So if neighbor is not a parent, then only you have to consider. If neighbor is not equals to parent, then if neighbor in visited, then we can say return false because there is a cycle. So this is not a tree. Otherwise, what we'll do, we will add it in our queue. Add in the right side, right? What we will add, we'll add this neighbor, and what will be its parent? Its parent is this node, right? So we add it here. That's done. So this is our BFS queue processing. Now at the end of this BFS, I have to check if I have traversed all the nodes or not, or all the nodes are connected or not. How do we do that? We need a count variable here. So every time I am processing one node, let's say I am just incrementing this count. So if there is a forest, we won't be able to traverse all the nodes. If you start from any node, won't be able to traverse all the nodes, right? So the count will be less than n. So we can, at the end we can just return if count equals to n, then we can return true. Sorry, this should be visiting. Yes, this works. Let's submit. and this is pretty efficient, like 100% bits, 100%. Time complexity is order of n. So if you like the video, please like and subscribe, and thanks for watching.